Good morning. I had a chance to do a little bit of work on the garage door project this morning, and uh, I found an interesting use case for my logic analyzer. Here you can see the project that I have outlined, and the logic analyzer is the little black box here, and it's connected by just one input because I'm only reading serial into the MB1040 sensor. Now, I have the app running, and one of the things that I was doing was getting the order of how stuff went in the main loop. I'm going to check the timers, check the parking progress, do stuff if the garage door isn't in motion. And I was noticing that when I did my reads, what I was seeing was a first read that would come back with a 0 in it. And it would only happen on that first read, and the other reads would then be fine. And I was like, well, what's going on? And this turned out to be a great opportunity to discover the actions of the MB1040 sensor utilizing my logic analyzer. So here is the logic analyzer information, and I have it connected to the circuit. And you'll notice that I have the trigger set for the first rising edge. Now remember that the MB1040 puts out, as you saw in the last video about it, puts out the serial information in inverted TTL, and I have a little circuit that captures that and inverts it so that it can be read by the Galileo. Now, what I'm actually doing here is I'm going to capture that first rising edge because the logic analyzer lets me actually read in an inverted serial. So I'm going to start that analyzer. You can see that I'm waiting for a trigger. And the trigger is going to be when the garage door is open. And you can see that we do this via this little magnet here, which will touch the read sensor and tell the read sensor that, hey, the garage door is open. So I'm going to put that in, and you can see that the little lights come on telling me, hey, the garage door is open. And if we go back to my logic analyzer, you can see here on the logic analyzer that I've gotten a bunch of information. Now, if you remember back to the previous version, I had the sensor running all the time, and we saw this information here. And if we drill into this, what you'll see is that R and then the 3 characters. So it was telling me that the distance read by the sensor was 52 inches. But when I was looking at it this time, I noticed that there was this big block of information that occurred up at the front. And so as I drilled into this, what you'll see here is I'm actually capturing this information coming out on the serial line on the start that tells me about what the actual sensor is. And it gives me a little copyright string and some additional information about it. And I was trying to read that information into my serial data, and clearly, if you look at the little routine that I'm using, I basically was just expecting the 3 characters, and once I had those, I was going to convert them from a string into an integer and return that distance. So I was not expecting this information to come at the front of the data. Now, I saw that 0 and I saw some characters and I was wondering what was going on, and the logic analyzer saved me from going and writing another app and reading the data in and finding out that I'm getting this string of information here. So what I need to do is I know from the data sheet that when you turn it on till the first time that it can take its measurement, it's going to take a certain amount of time, and I need to deal with that. And so in my code, I had, in terms of resetting the sensor, I had that delay, and it gave me a chance to turn the power off, turn the power on. What I wasn't aware of was this string of information that came in. And so what I need to do is ensure that I have gotten rid of that string after the sensor is initialized and it's returned that. So now I can go and make the change to my code, get rid of this string that's going to come in and all this data, and then once my sensor is ready to run, I can start just simply looking at this data there. So that's just a quick example of utilizing Logic Analyzer to make the entire process easier and to discover what is going on in the uh, when you don't expect things to be happening in your circuits.